This is the foundation lesson for 3D shapes 15.1. First thing we're going to talk about is the vocabulary. So we've got a face, which if I've got my 3D shape here, a face is a single surface. So here, top part is a face. We've got lots of different squared faces here. An edge are where two faces meet. So this line, each of these edges here is an edge. So this part here, and we've got 12 of those in total on this shape. And a vertex is what you'd normally call a corner. So each of these corners where three faces meet. So for example here we've got the red, the white and the purple edges meeting right here. That is a vertex, and we've got 8 of those on this shape. Other shapes that we definitely need to know. So this one's a cube, but we need to know what a prism is. So a prism has got a constant cross section all the way through. That means that if I took a slice of the shape, it would appear the same every single time. I like to think of it like a loaf of bread. And then a pyramid, which normally we might see as a square-based pyramid or a triangular-based pyramid, where they start at a square or a triangle and then meet up at a point at the top. Now I'm going to show you a couple of nets for the shapes that are shown here. Okay, so I've drawn them quite basically on a bit of plain paper. They're not perfect, these examples, but I've given it a go. So a cylinder, we've got our rectangle around the middle, which is actually the whole surface, the curved one, which are not the circles. Here we've got the circles at the ends. Okay, think of it like a Pringles tube. If you cut down the side of the Pringles tube, you'd be able to open it up into a rectangle. We've then got a triangular prism, which are made out of rectangular surfaces around the edges and 2 triangular ones at the end. They've described it as a square-based prism, which probably could be described as a cuboid as well, but they're specifically talking about ones which have got squares as the cross-section all the way down the middle. And then there are 3 examples of pyramids along the bottom, where we've got a square-based pyramid which is going to have a square in the middle, a triangular-based pyramid with a triangle in the middle, and then a cone. Now a cone looks quite different, but it's still kind of a pyramid, because it starts with our shape at the bottom and meets up at a point. Now these are all nets that I've drawn over here, because you would be able to cut around these shapes, fold them up, and you'd be able to make the 3D shape again. Okay, so what we're going to do is look at lots of different shapes. I'm not going to talk about the examples in the book, because the examples in the book are very simple. Okay, what we've got here is a different shape that I'm going to be able to look at. So if I'm saying this is my 3D shape, I've told you it was a cube before, and I put it like this, okay, then there are 3 different ways of looking at it. The way we're looking at it right now with the camera is what's called the plan view, so from above. Okay, it's what a bird might see, the bird's eye view. And you can see it's clearly a square, and if I rotate it around, we've still got another square. Now there are 2 other views that we might care about, one being the front, which is coming from this way, and one being the side, which is coming from this way. Now I like to say when I'm in lessons that if we were a very small person looking at this object, say this Lego man, I'd be looking this way at the image. So look, he's looking at it like this, meaning that he can see a square as well. And then if he was moving to the side, he would also be able to see a square. So if you're ever asked to draw a front, a plan and a side elevation, for this shape you'd be talking about squares. So for example here, we've got the plan, the front and the side elevation. Now I've exactly drawn what it was, because here there are 2 by 2 squares and here it was 2 squares by 2 squares. Okay. If I was asked to draw this in 3D, I'll bring it back. Fold my paper. Then using either plain paper or I've used isometric paper, I've been able to draw exactly what was there. Again, 2 by 2. And if you look, I've kept everything as parallel as possible. I've used a ruler, and again we can see that the faces, we've got the plan, the side and the front elevation as we'd expect them to be. Now we're going to look at 2 more which are quite similar but again different. So if I keep the same amount but instead make this shape, okay, so look at it in 3D, it's sort of an L shape, think of it like a Tetris block. Okay, but if I put it down like this, we can immediately see that the plan elevation doesn't look like an L shape at all. In fact, the plan elevation, let me just turn it like this so it's the same as my little diagram. The plan elevation looks like that, okay, because I've got 2 and I've got 3 squares like that. The front elevation, well, if I was the Lego man and I'm standing here looking forwards, then you'd be able to see 4 blocks, and even if it was actually this way round, you would still see 4 blocks. So if I turn like that, this is the Lego man looking down, you can still only see 4 blocks, okay, whether it's this way around, ooh, ignoring that, or this way around, okay. And then the side elevation, if he's standing over here, looks like an L shape, and if we turn it just so we can see, that's what he can see from the side. Okay, and again in 3 dimensions I've given it a go at drawing it, being very careful. Okay, to keep all the lines parallel as possible. And I've just downloaded that isometric paper offline if you wanted to have a look at some of that. Okay, the third example we'll quickly have a look at is if I opened this up and just had this cuboid here. Okay, so if I plonk it down like this, put my front back on, straight away we can see that the top, turn this around, straight away we can see the plan looks like a 2x4 rectangle. That's exactly what you can see right now. Okay, the front elevation, let's have it like this, the front elevation I've drawn is 1 rectangle by 4 rectangles, and as you can see, 1 by 4 rectangles, that makes sense, 1 by 4 as a rectangle. There we go. That's what the Lego man would be able to see if he was looking at that. And then if he moves to this side, the side, he'd be able to see a 1 by 2. And if I tilt it up, close that, there we go, 1 by 2, we've got that. Okay, if you want to see what I've drawn that in 3D, it looks like this. We've got 4 down one side, 1 up and 2 across. 4 down one side, 1 up and 2 across. Okay, thank you for listening. I hope that explains what you've got to do on this section.